In this lesson, we'll be looking at the chain rule, which is a really important part of dealing with derivatives in calculus. And it's pretty hard to explain, but I think I know a good way to lay it out for you. So, up until now we've seen pretty simple examples, but what if we had something like x plus 1 squared? And you wanted to take the derivative of this expression. Now, how you do this is by using the chain rule. And what the chain rule says is that you go outside in, outside in. So, this is how I think it makes sense to explain it. You go from the outside to the inside. And so what you do is you ignore the inside, you take the outside, take the derivative of the outside, and multiply by the derivative of the inside. So let's say this. I'm sorry, I made a typo. Take the derivative of the outside and multiply by the derivative okay, sorry about that typos there. But this is really what the chain rule is. Take the derivative of the outside and multiply by the derivative of the inside. So the derivative of the outside is you pretend this x plus 1 is 1 unit. You take the derivative of the outside. So we have 2 times x plus 1. And then this power here goes down to 1, so what we're left with is just 2 times x plus 1. And then you multiply by the derivative of the inside. And the derivative of the inside, the plus 1 goes to 0, and the x goes to 1, so this is just 1. And what we're left with is 2x plus 2. That's the derivative of this expression. So let's try something a little more complicated. Let's try x cubed minus x squared. Just like before, we pretend the inside is 1 unit and take the derivative of the outside. So we get 2 times x cubed minus x to the first power. And so multiply this by the derivative of the inside. So the derivative of the inside is 3x squared. 3x squared minus 1. So there you have it, that's the derivative of that question. Now, if you keep your eye out for when you have multiple of these, you have to repeat this process. Like if you have multiple exponents. So if we had x squared plus 1 squared plus 2x, all this cubed. This is a really nasty example because there's so much going on. But using the chain rule, we can do it. So let's pretend that this entire section in here is 1 unit. So we take the outside, just this cubed part here, and take that derivative and multiply by the derivative of the inside, just like before. So what we get is 3 times, might have to do brackets here. Okay, x squared plus 1 squared plus 2x. This whole thing goes squared. So that's the derivative of the outside. Let's do 1. We have to multiply by the derivative of the inside. So I'll just do the second term first. That's just going to go to 2. Derivative of 2x is 2. But what about this term? It's clear that we're going to have to repeat the process with this. We're going to have to do another chain rule. But if you remember how the chain rule works, it's easy. You just do the outside. 2 times x squared plus 1 times the derivative of the inside again. So the derivative of this inside is 2x. And that's it. Now, I can do simplifying here, but on the AP and your teacher, if they're reasonable, will let you leave it as this, because this is just the non-simplified derivative, but it still is the derivative. So if I gave you a value for x and you plugged it into each of these spots and evaluated this, you would get the slope of the tangent line at that point for this crazy function here. So that's all there is really to the chain rule, but because it's such an annoying process, not annoying really, but because it's something that just takes a real understanding to be able to do, we can do another example or two. So I'll clean this up. Let's just do a couple more. So why not x to the 4th minus x squared cubed. Here's another example. So we go outside to inside. Outside, we get this. And I didn't really mention this before, but you always leave the inside intact like this. Just outside, pretend it's 1 unit. Sorry, you go from that outside to inside, 1 unit. So now we multiply by the inside. This is 4x cubed minus 2x. And once again, we look in here, there's nothing in here that's unusual. Nothing complex in here, nothing requiring the chain rule, so we're done. And so this is about it. That's about as much as I can explain the chain rule. And so if you guys think that this isn't sufficient, let me know in the comments or send me a message, and I can do some more examples. So thanks for watching, and I hope this made sense to you. See you in the next video.